Okay. Hello all. Welcome to this session, which is hosted by Pranit for making sure Gluster's knowledge, the developer knowledge, is available for everybody. So today, okay, let me introduce myself. I'm Amar, and I'm with Gluster FS project since day zero, I would say, and currently one of the maintainers of Gluster project. I'll talk about networking layer, its history, how it is done, how you can walk through code, and all that today. We'll try to cover as much as possible. I'll keep the time at the end to ask questions, answer them, if that is okay. Okay. Cool. So what we will talk today is uh, generally to understand why networking in a file system, first thing, and then what is a protocol, what is RPC, and what is XDR, which we talk in, like there is a mention of all that and in the code, and specifically Gluster's networking layer, and history of it, how it evolved and things like that. And we'll quickly go through some code so that at least one FOP will go through how to walk through that. And then we'll look at the challenges and also the roadmap. So if you are interested to contribute to Gluster project in the networking layer, what you can do in the future. So we'll cover all this if time permits. Otherwise, of course, we'll continue this session and the following series. Cool. So network in file system, right? So what we call Gluster FS is a distributed network file system, right? So which means, what it means is it is a client server architecture. It's not just one machine which is involved here, like maybe ext3, ext4, xfs, zfs like thing, where drive or a hard drive in the same machine is mounted and given to the users. So what happens is here, data will be on the servers, access will be on the client, which means there will be multiple machines involved here, and data will be in the server and access, whereas which is client can be thin, or it can be a client is just a process, but it is accessed by the client. Hence, and networking is very, very crucial. And looking at little bit of a Gluster, how it is handled in networking. So the connections are initiated by clients, of course, and server generally is in a listening mode. And this is how any client server architecture is. And if you know any websites and things like that, right? So generally they will be listening on port 80 and things like that. And clients are initiating the connection. Similar here. But the difference is Gluster uses TCP connection, which means it always, there will be a channel which always exists. It is like a file FD, but we call a socket. So that always is there. So you can write to the socket and it will be received on the other end. And most of the operations are initiated by client. So please note the difference here. I'm talking all the connections are initiated by client. That is different from operations being initiated by client, right? So because connections are the first time activity, once connected, you will always have the connection established, whereas operations are triggered by the applications and stuff on top of the file system. Here, I'm calling it most of the operation mainly because there are something called a callback, okay, which is initiated by server also in our RPC architecture. So generally, a basic client server, this may not be there. Server may not initiate something. If you are aware of some web related technologies in these days, it is like technically a WebSocket where server also can push some notification to client, right? So it is similar. So there is a callback method which is used as a notification in Gluster also. Let's look into protocol next. So when we talk about protocol, so there are, as the English word means, it is something which is about the order, right? What is the process of things, what is the order of events and things like that. That's called protocol. And it is in the networking or in the file system, it is established for how is the order of data, what happens, and how the request is found, how the response is done, and things like that. So for example, when we talk about protocol, examples are HTTP, TCP, IP, both of them. The P in all of this stands for the protocol. SSH, technically it is not a protocol. It is application, I would say, but it is also can be protocol, because to make a connection there will be a standard. So things like that. So, and if we come to Gluster FS, it uses RPC and XDR combination for networking protocol at present. Okay, so we'll talk about what is RPC and XDR in a while. So let's look into what is RPC first. So RPC stands for Remote Procedure Call. Okay, so what it means, I have a link. Once the slides are available online, you can look into this RFC. It has more details and on how to, or how it is implemented, all the details and stuff. So it is a newer version of the earlier RPC. So this should give you a lot of idea. So to give a very top level, or say 10,000 feet overview, a regular function call or any procedure call in a computer system you do in a machine, you will call a function, it gets executed and get a response back in the same process, right? So whereas in a remote procedure call, what happens is you call, there is a network, so the call gets executed in a remote machine and the response comes back to you, right? So this is the idea of a remote procedure call. So how to implement it is a thing which applications will decide, but RPC gives an standard for implementing this and a basic protocol on that. So that is what is written in the table here. At the top is RPC message, how a RPC message looks like. So each message starts with its own transaction ID. XID means transaction ID. And then it will see if the type is a call or a reply, right? And if it is a call, for example, there is a call body. So again, it is a union. So again, the structure. So this, I believe you all are now initiated with C, because Gluster FS, of course, is in C. This is how the structure looks like, right? So the call body, of course, comes to RPC version. It is hard-coded to 2 today, because RPC everywhere is version 2. And then there is a program number, and then there is a version for the program, and then procedure number. Okay, so this is critical for us to understand which is the actor or which is the procedure to call on the remote machine, right? So because as a service, it is technically like if you are aware of web, it is like a routes, right? So each API endpoint can be different, and that is listed by the routes, and by calling the particular path, we know where to reach. So similarly, it is done in the RPC. So the combination of these three should be unique and always be pointing to one of the functions in the remote machines. And the opaque auth cred, opaque auth where, WAF means verification. So these are used as a authentication layer in the RPC. This can be null, which means you can say, I don't have to do any authentication in this. So, and things like that. And after this is where there will be procedure specific parameter which starts. Okay, that is where XDR comes into picture. Okay, now let's look into what is XDR. You can all, I mean, I will always come back if I'm too fast for your speed, but for now I'll just try to cover as much as possible. Hope that is okay. XDR stands for external data representation. Again, there is an RFC for it, how it is implemented and things like that. Okay, so this has a standard, which it means is how a data is represented on the wire, right? So how a client, whatever it packs in the request, how it is understood by the server, and how to decode it, how to understand the message and things like that. Okay, so this is specifically used for procedure specific payload. What I mean by procedure specific is, for example, in Gluster terms, we call FOPS, right? So which means file system operations, which Pranit has covered already. So that is actually what is a single procedure in RPC world, right? So open is a procedure, lookup is a procedure. So the request or request parameters for each of these are packed in XDRs. Okay, so they are used for it. And the very primary thing to understand is the client sends the payload and server expects it in the same order. The moment you try to do something else, the server will error out saying I have failed to decode the message. So that is That is a very, very key thing here. Now, that is about very top level of networking protocol, RPC, XDR, and Gluster. Let's look into history of networking layer in Gluster, right? So what happened in version 1 of Gluster was we had binary packing of structures. What it means is you know exactly how much is being read on the packet or being sent. And what we used to do is just, as I written here, right? It would be a single function call, which is on the socket. You just write the structure directly and decode it. And you would just use the packing attribute of the C compile time option for that structure, and you just unpack it on the server and read it. So this works as long as the machine types are same, OS is same, and things like that. Whereas it is not easy to manage a card, I mean, with multiple versions, because the structure would get new variable or something and everything would break. But this does the job. It helped us to do the POC initially and to prove that, hey, as a file system, we can build Gluster and stuff. Once we did that, then version 2, we actually moved to dictionary being the protocol. What it means is, in dictionary, if you are aware and you want to go through, there is a way of packing and unpacking, right? So what we used to do is write everything as a key value in dictionary, and then just like encode it as a string and pass it to server. So the server would anyway know that, hey, because it is as good as a write and read there, right? So reading, we get to know how much is the size, and we decode it as a dictionary because we know that it is a dictionary, and we would handle that. There were multiple issues in both of these. With a dictionary, it was easy to handle multiple changes or version changes. We didn't have to bother too much. Only thing was we had to bother about whether a key has to be managed or if the meaning of the key changed. Other than that, it was actually heavy on the CPU because it was a string encode decode. It was a little costly for us. So what we did next was we got NFS into Gluster by version 3. Because NFS was based on RPC, we had to do the RPC and XDR. Because there were RPC already implemented for NFS translator, we actually use that for Gluster FS also. So from version 3X, which is almost, I believe, 10 years now, it is there. The version, I mean, we use the RPC and XDR method itself as a Gluster's protocol or networking layer. Cool. So let's look next. So Gluster's RPC layer. So if you are interested to look into key components of Gluster's RPC layer, first thing to look into is as a translator code, which uses RPC, is generally translator protocol. Okay. And I'm mostly talking about file system here, not the management layer, even though management layer also uses all of these. So, and then there is a library code for RPC server, RPC client, and there is a XDR definition for each procedure. So all the functions which need to be handled over the network had to be defined with a XDR or a payload. So that is very crucial, and hence there is a lot of code here. And XDR, there is something called RPC gen, which will generate RPC code for given XDR. So we use just XDR generated, I mean, encode decode functions. Using that, we implement our own RPC. We don't use RPC gen for server and client procedures. So those are the things you need to be aware of. And if you come to network layers responsibility, what it needs to handle is especially connection management. So how many clients are connected? How do you reconnect? How do you manage this? And how do you know exactly this is successful handshake and things like that? Then comes the RPC, which means, again, implementing the programs and program table, keeping that in order. If there is a change, implement one more program table, manage that in the handshake and things like that. Then you have to handle notification, which it means is if there is a callback from server, then you have to notify the same, or if there is a disconnect, you have to notify and things like that, or there is a request or a response you have to handle, right? And it also, Gluster being a modular project, right? We had to handle modularity in terms of TCP/IP being a different way. RDMA was a separate type of transport. It doesn't use socket connections, right? It uses remote direct memory access. So that is those are the things we had to consider. So even though it is not supported today, but our networking layer was designed for modularity. Yeah. Let's go through code quickly, and then we'll come back to the presentation. Okay. So what we will try to do is we'll just open the code, go trace the open callback, open function, what happens from client, and then understand what happens in the XDR. And then we'll not get into the next networking call completely because it has multiple layers, but think of it as it is a write on the socket when it goes over the RPC, and how the server actually handles this. And then we'll look into the payload and how the response comes back, right? And to know this, so when the response comes back, there is no procedure number and stuff. When the response comes back, it has a transaction ID. So we will have to maintain a table in the client where pending request will have to be there, and it will be a lookup based on the transaction ID. So that's how we get back the to continue. Okay, give me a sec. That is okay. Let me share more things today. Window. Okay, too many windows. Okay, is it visible? Any? You want this to be big? This is okay.
Yeah, do one more also if it is possible, because of the recording it actually pads something at the right side, so the font generally becomes smaller. So you do one more.
Okay, this is
yeah,
better.
this is better. Yeah.
Okay, cool. No
it will go to the previous one after the recording, but yeah.
Yeah, no issues. Cool. So now this is, I'm in the latest code, not this. Okay, I was doing a double change. Ignore that. But other than that, I am in the latest change as of today, right? So let's get into the call. So the accelerator protocol, I said this is where you have to start looking into. So you see there is a server, there is a client, right? So we'll start walking through the code based on client. And if you see, the first thing which happens in the client, so you see this is the program which I was talking about. So in RPC, so I said there is a program number and then the version number and then the actual procedure number. How it is handled is like this. So give me a sec. Where is the version and programs? Dump program, handshake program. Okay, RPC FRP2. Let's go here. So you see this is how the program is defined. So this is technically our implementation, but what we need to pass to the RPC structure is the program number here. This is a program number. So this should remain same for particular program, so that you can develop tools like, for example, Wireshark and things like that, right? So if anybody decodes this RPC call, they can understand, hey, this belongs to Gluster. Like how we can separate a request from NFS versus Gluster versus things like that. This is how it is done. And then there is a version number. So these two are specifically required for RPC call, and we fill this in when we call the RPC. Okay, and this numproc is like how many procedures are there in this particular program. So this has to remain static for a given version ideally. And generally what we do, because Gluster is still under development, we add a thing at the end so that it is generally doesn't break things which exist. So this is how the actual actors here are. Okay, so what we are doing here is each of this is a enum, which is just a number, right? So but there is a function which is mapped. This is used for a lookup call. I'll show on the server. It is more critical because based on this procedure number, we call that particular function from the RPC layer itself. So we pass that as a program for the RPC layer while initializing. So this is very key. So you understand now that, hey, you have all this program number, versions, and procedure counts, and based on the actors, right? So we get to know which is the procedure. So now this is how we can actually have different pointers and different modularity. For example, if the server doesn't support a 4x version, so we will have to use 3x version, and at that time again the same actors would be there, and we can't keep changing the translator code for it, right? So that's why we need to handle this, and that is handled in client common. Yeah, where is this? Open, client open. So what we are here is client open call, for example, right? So this is called generally from a stack wind call of the translator above client. So if you see all this, the signature is same as translator signature or a FOB signature. So it comes here, we build all the required things and just do all the handling things. So what we check here is, this is where I was talking about modularity, right? So we check whether what is the actor or the function for the open function. So this is set during the handshake. Okay, so we decide the handshake and handle this, and yeah, so then depending on that we pass the arguments here, so and we call the function. Okay, so this is where the process proc function is called, and you see generally we are in version 4 now, so that is handled in so this is client src client RPC v2, right? So we'll go to open here. Yeah, this is the 4.0 version. So we call this from the client. And here you see that what we do is all this, and we pack all of this and we just do the submit, right? So this submit actually is a submit request where we pack with the XDR format and handle the XDR here.
Amar, you are on mute.
Yeah, this is where the first part of the XDR comes. GFX, okay. Yeah, so this is the open request. If you see, this is the exact way. So what we are calling in the other place is the XDR GFX open request. So this is a generated function by RPC gen, and it actually packs the data based on this content. So what it has is it has a opaque GFID, which is a byte, 16 bytes, and then it will actually look for next 4 bytes as a integer, which is unsigned, and then it will actually look for a dictionary, right? So this is how it gets packed and sent on the wire. So we use IO buff here mainly because we supported what do you call RDMA, where we needed to actually have a separate buffer for the payload data for read and write, so that it would actually RDMA. So it is helpful. This is where actually the client will actually submit all this. So you see that it has so many parameters. So the program number, callback function, IO vector count, and all these things, right? So once this is submitted, so generally it is received on the server. Let's go to server code for understanding more. Again, coming to this function, this is where again the program files are. So you see that there is a difference between a server program and a client server. So this helps. So now here also there is a program number, program version, and all this, right? So the actors here are chosen based on how the code is handled, right? For example, I sent JFS3 open or op open. Yeah, this is a function which is to be called here, because this is using the function call. There is one more call, this null you see everywhere, that is used mainly for the payload. Okay, so give me a second. Where is the open? Yeah. So server open, you come here. What happens is, again, at this time, actually by the time it reaches here, the RPC header part, which I showed, the call body, decoding the program, decoding the, what do you say, version, decoding the process number, all of that is done. So that is where it figures out, hey, this is an open call which is requested from the client. So I have to call this particular function. So the client, whenever it sends, because it has sent all the procedure number and stuff, it will reach, the function will reach here. It is technically like how the stack wind works, but over a network, right? So that is, all of that is provided in the argument, and the RPC layer or the library part will take care of calling this function, because client has called a request with the open arguments. So the whole thing comes here with the XDR being packed. So you see it is using the same XDR here, XDR GFS open request. So, but it actually does receive function. So there is a way to decode and encode in our XDR. So the generated XDR files, right? So I'll show in a while. So they have a mechanism to encode and decode it separately. So on the server side, it actually does the encoding. So if you change it to, for example, open dir, or say, for example, write or something, right? So immediately this will fail. So you see that this error happens actually. So we need to make sure whatever is sent by the client is the same thing which is decoded on the server also. So that is a very primary thing when you are implementing a RPC calls. Okay, so that's mostly it. And from here, what happens is, to talk about more of the protocol, this is like how the fuse works. In the fuse, you don't get all the LOC or the location details, right, or the inode details. So similarly here, so all we get in the wire, if you have seen, was where is that Gluster Dev is the GFID. Hence, we have to resolve this and continue, right? So if you see here, by this time it is all resolved. So we do the stack wind. So the whole graph structure continues properly into the Gluster FS. So that's mostly how the basic networking thing or the RPC works. Okay, let's look into a little bit more on the XDR, how it is done. So any questions so far?
Amar, maybe even the response path also, if you can spend like 2-3 minutes, that would be great actually.
Yeah, sure. That makes sense. Sorry about that. Yeah. Okay, so you see I was in open resume. So what happens here is by this time the call is in Gluster FS context, in a way that your location and other data is built, inode is found, everything is done. So it is able to do the stack wind. So what happens here is stack wind, stack wind, how the arguments is, how the connection is. So the response comes back to the server for open callback once it is successful or a failure, right? So what happens again? So we have to now decode it or encode it back in the wire and send it back, right? So again, so you see that we do the XDR open response here. So there is a difference. Earlier one was a request. If you see, this was request. Now it is response, right? So we'll just check the open response thing. So you see all it has is operate, operno, what is the X data, what is the FD. So this is what we just encode here. So all of that is actually set. If you see, response is the one which we have as GFS open response, right? So it is the same structure. So it is also, if you see, where is this? So this is the XDR. We just do this, and based on the XDR, so we generate a file, which is the Gluster file. So we'll go through that. When I build, you see RPC directory. Build RPC. Give me a second. Yeah, so you see here there are already .c files, whereas in the code you don't see any .c but only X files, right? So if you see this is where Gluster GFX open request. So this is the structure. It has all this type def added, this added, so all that open and request. So this is how the structures are. And if you see the file here, the .c file, so it is again same, right? So you see that open request is XDR opaque, so it knows exactly in the same order. So this is why you can't change the object. The moment the order changes, even if in the structure, the complete thing fails. Okay, so and when you go to, for example, opaque, all these things, there is a encode decode. This is what I was talking about. So XDR exactly knows whether it is an encode operation or a decode operation, and based on that it actually handles the decoding, or rather the XDR functions. So this is how most of the complex structures are. This is because IAT had so many different fields, right? So this is there. Even GFX dict, for example, has so many complex things. For example, it is array and it actually goes to dict pair. Dict pair is here, dict pair, and it is again same thing here, and GFX value, and GFX value is all this, right? So yeah, so this is how the dictionary gets encoded in the XDR. So what I'm getting to is this is generated by the so there is a RPC gen call. Yeah, you see how the source files are generated. That is how we generate a C file first. RPC gen takes -c as an argument for generating C files, and as in source files, and the header files, so RPC gen head. So headers are generated this way and source are generated this way. So this is how we actually convert the XDR definition into actual function calls and all that. This is automatically generated and available only in the build path. So going back, so this is what happens. So on the server, we do the function callback. So server submit replay. What happens here is it is generally sent. JFS, we serialize it and send it. The XDR proc is server. We know exactly what it is. So once it is all submitted, what happens is it comes back to the client RPC v2. So client actually open callback. So this we come back to this because we pass this argument, and this is stored in the table for the given function. So if you go here, the callback was callback function. You see that it was stored. It is passed to RPC also. So RPC itself, client actually. So it is request is stored as a structure, and we do the search in top of it, and things like that. So the end, once say for example, this is when the response comes. So this is when actually a successful response comes. We don't have a best, what do you say? No, this is not when the response comes. This is forced unwinding. This is when the response comes. So this is when the handle reply happens. We know that there is a from the transport layer, we know that there is a pull in request, which means there is a response. Then we decode that. Okay, so then we understand, okay, hey, this is a callback function based on the, here is where saved frame comes from. Saved frame is looked up based on the XID. This is what I was talking earlier, right? So we only look into the very top head of the what do you say, request, and allow everything else to be decided by the program. So just the XID is enough here, and N to H and H to N stands in network layer for network to host and host to network. So they are done majorly to handle little Indian, big Indian architectures. So yeah, so this is how generally RPC is implemented. So this is where the lookup happens in a table. For the connection, there is a table of what are the requests sent and things like that. So based on that, we get the frame back, and frame has all the requests. And based on that request, we do the callback function. And from the callback function, we do the, yeah, so we come to this callback function. So this is where, again, if you see, we first convert XDR to generic, which it means is we decode the content in the XDR. We got it back in the response. And from the response, we understand what is the behavior and all that, and just pass back it into the Gluster stack as an unwind. So that is mostly how the networking happens. From client, it initiated, reaches the server, goes back and things. And if you see, there is little complex implementation of how do you read a request and like step-by-step read of this. That is most of a state machine thing for reading, because if you see, RPC is like multiple what do you say, unions of structures. That's how networking layer is. You read first 4 bytes which are understood, and then based on what is that value, you read further so many bytes and then make out what it is and then continue. That's how it is done. And for example, authentication layer, we use Gluster authentication, which is majorly used for because every request on the Gluster goes with a UID, GID, and a PID, and all those things, right? So what we did is we moved that to authentication. We don't do any authentication as such, but we reuse authentication layer to send that extra common information. So things like that. So you can handle all those, and we do that. And yeah, this is mostly how the Gluster's code is. Let me get back to this. Is my screen visible or no?
It is still Emacs only.
Yeah. So let me come back. And so, I know it is not, may not be complete with all the information, but this is a good starting point. I'm happy to help you to read further. Considering we have only 15 minutes, I'll continue. So what are the challenges? So the one thing with networking is one and foremost thing is actually version compatibility or backward compatibility, right? So you have to make sure XDRs remain same. If it is a requirement to change something on the wire, then you need to make a version change. So it is a challenge. That is where, if you see so many projects like NFS, for example, so they do a committee meeting for finalizing this thing very, very clearly, because there are so many companies who implement their own software to access networks, say NFS server, right? They may have their own inbuilt client. So if you make one change without knowing, it would break everything else, right? So none of the softwares would work, or your server would not work with other clients. So that's the reason why it is very, very key for doing the protocol changes with very careful thing and properly documented, make it as a version change and things like that. So that is very, very big thing. Then uh, the biggest challenge what we are noticing now, when we did it, it was okay, mainly because networks were not that fast. The CPU was faster than network and the overload was lesser. But now with 100 Gbps and NVMe and things like that, we were performance of XDR encoding, decoding, RPC, multiple system calls to read small segments in the request are causing a performance hit. So that's where it is one of the big challenge. We have to relook into what is better and things like that. And yeah, so you can't, I mean, we can't expect all the nodes in the network can be updated one shot. So it is a mandatory thing to handle proper handshakes and understand versions properly. Cool. So again, I want to talk about procedure numbers. Enums don't introduce anything in between. So we recently had a regression because of this. So something, it looked like, hey, there is a handshake. Like next to it is where we will just add a handshake version 2, right? So while developing, it may be tempting to keep it, what do you say, sorted based on name or something. So don't do that. It is all based on the numbers. So ideally it has to be a new version and new table and new program itself, but it is okay to add it at the end, because we are still developing, still evolving. But if you add anything at the in-between state in XDR files or anything used in the XDR, it would break version compatibility. So keep that in mind. And yeah, so that is what I want to stress again. Coming to interesting part, what you can do further. Yeah, so one thing which has evolved and people are saying is better is, instead of XDR, they are using protobuf, which is like technically structure packing type. So people are saying it is better performant. Some of the competitive products have moved that way, and it is actually giving them better performance is what they're saying. And RPC layer also, there are current RPC, not many takers, not much development happening, whereas gRPC is available. Sadly, gRPC doesn't have C module, but it is a good thing to keep a lookout for. And we need modularity, because RDMA, even though it was there, it was not actively tested. So we need to relook into that and relook into enabling RDMA again. And the future, yeah, duplicate replay cache. So this is something which is technically part of the RPC, but not a basic communication thing. This is a thing where, for example, right, if you are sending a request to server, say connection dropped, you want to reconnect, but you never got a response for the previous request. You don't know whether it was completed or it was received by the server or anything, but you resend it. At this time, not every operation is idempotent operation, so it is very hard to say whether it is possible or not. So that's where duplicate replay cache is required. So this should be handled in the server side, where it understands, hey, this is a request which I already received and handled. This is a request which is in progress and things like that. With this, actually, our network can actually withstand minor glitches in the network. So that is a very key thing for us. Cool. So yeah, that's the thing I had in mind. So especially thanks to Pranit for coming up with the idea and especially following it up with sessions over the time. It is easy to come up with the idea, but doing it out and spending this 1 hour and preparing for it is not easy. Especially if you want to reach out to me particularly, you can reach out on Twitter. I can reach out to anything. I'm using Kadalo.io because Kadalo.io also is heavily invested in Gluster projects, and it is trying to improve Gluster for the newer versions, newer things, and you can reach most of us in Gluster Slack or reach out to our community mailing list or GitHub and things like that. Or you want to know more about Kadalu, yeah, you can reach us on Kadalu Slack also. And Kadalu, I was there. Cool. Any questions? Anything? Open for it.
Actually, my thought was on the Amar was mentioning the last, right? You want to move to gRPC. Is there any work we are planning to do? Or?
So it is an open item, I would say. The reason is there is no collaborated effort which has started. One of the challenges we had was gRPC is not available with a C client for it, C library. So that is a major blocker right now. We haven't taken time because there are other things where we can optimize Gluster and build features and stuff. Every maintainer or everybody I know of are working on those Gluster specific things. So networking layer, we haven't worked on it.
Yeah, I think Vinayak in this call, he has done a small POC with gRPC and he found it a bit bulky. So I was just thinking it's a critical layer of, very critical layer of Gluster. So it's a right time to do it.
So there is no right time. The one of the things to note is the current RPC is 10 years old, right? So it was good at that time. So things have moved on. There are newer things, newer hardware, newer technologies, and newer projects which are well maintained compared to RPC as such, right?
Okay.
So that's also a reason. I mean, being an open source project, we also have to understand the things we depend on. For example, networking and stuff. We will have to be aware of the maintenance status of those projects also, and hence the suggestion of moving to gRPC actually.
Okay. You mean libgRPC might be again obsolete?
I'm not sure. I mean, see, absolute. I mean, for now it is good enough. At least I don't see it being absolute because NFS is always going to be there. I don't see NFS going out of business at all. Right, but but the thing is, current RPC layer of Gluster is known to have issues, as in especially performance issues. Right, so that is where I think there is a perk for improving or spending some effort on it, but it is also something which we have to think of it as a priority.
It's a heavy investment. I felt like.
Yeah, it's a time investment.
Yeah.
Exactly.
Okay. Thanks, Amar. It was pretty nice session.
Yeah, Amar, I have one thought.
Yeah, sure.
So for server configurations and most of the configuration parameters wherein we have handshakes between the server and we pass on, like, for example, there is server A, and say we just rebooted the nodes and 5 or 6 servers came up. Now, the current methodology of how we pass on the parameters is like each of these servers perform a handshake and they share their configuration details with each of them one by one. It's like, hey, I'm server A, this is my configuration. It tells this information to all these servers one by one.
Correct.
And this is, I think, a bottleneck if we see when when we want to increase the number of servers or maybe we want to expand horizontally.
Oh, yeah. I mean, so what you are talking, Srijan, is specifically to management server of Gluster, which is which does a mesh networking thing, right? I mean, I am a proponent, and me and Arvind are always on a path saying current management layer has a lot of bottleneck in that sense, right? And hence that is a known thing. So it is to be optimized there for sure. So
Yeah. So
yeah.
So my question is, like, I was exploring the D2, and I'm not sure, I haven't gone completely through it, but I see the Kubernetes uses etcd for the configuration management and other. I mean, basically that it's a separate layer itself, but still it will
Correct.
fix the issues we have most of the times, which I've seen.
Correct. That is true. So that's what was tried with Gluster D2 implementation. And for example, with Kadalu, we took away Gluster D by focusing on keeping it in config map in Kubernetes, because config map is available for everybody, and it's an external layer. I agree, but it does solve the problem, right? You don't have to keep per node specific detail anywhere. So yes, I think we have to relook into that, where we can utilize something else as a option instead of switching. And one of the customer who had hundreds of nodes, right, where the frequency of failure was high, they had major issues with this, because when say 30% of the node came up suddenly, there was network was blocked because of the handshake request itself. So
Yes.
things like that.
True.
So, I mean, I understand management layer. I would not talk, or rather haven't focused in this particular thing, because management layer uses the RPC. It is the logic of the management layer which has a problem here. So it doesn't come under networking layer per se, right? So it is, you can technically change the logic of how the handshake is done in the application or the management layer itself without getting into RPC or the networking at all. So that's what is the solution here.
Okay.
Okay.
But have we
To add
okay,
to this one, so Srijan, I also thought about this problem. One way that I thought we could change this part is to limit the number of nodes that actually store the configurations, and convert all the other Gluster as listeners. Okay, so let's say to give an example, you can set the storage nodes, like the nodes that actually store the configuration, to be, let's say, 7, and all the configuration would just stay at those places, and all the other ones, right, will just be listeners. So everybody will connect to just these 7 peers. Okay, does it make sense?
okay.
Instead of connecting to everybody else, they will only connect to these 7. So the next step is something like if you want to do like peer detach and peer probe, right? Peer probe is easy, but when you have to do peer detach, and one of the detached nodes is the one of those 7 nodes, then you have to do something special. So but like, this is something that has been done in, like, Zookeeper. I think I probably even HCD has these listener node concept, I think. But that probably is an easier feature to implement in Gluster rather than coming up with a new config store and all of that, is my personal opinion.
Okay. So well, now previously I had worked a little with the messaging systems. So wherein we have the concept of topics and payload. So wherein we completely remove the idea of server and client. Now, only specific to the configuration management have we ever thought probably if that will solve our issues or?
No, not really. So the reason why I was suggesting the solution is because it's a comparatively very small change to solve that particular problem rather than an overhaul. Yeah, so that is the reason, because all these things, right, whenever you want to change any of the things, like even whatever Amar suggested about gRPC and protobuf, essentially you are breaking compatibility. And because Gluster has been in use for such a long time, people generally hate it. So that is one more reason why I was thinking in terms of listener node and storage nodes rather than like an overhaul.
Okay. Okay. But yeah, I guess we can take this conversation and see how we can improve this part.
Sure, definitely.
Thank you, Amit. Thank you.
Cool. Any other questions? We are at the top of the hour, and
So Amar, like if we replace only XDR with protobuf without changing RPC, is the benefit is considerable, or only along with the RPC change it will be more beneficial?
so not sure because we haven't done that experiment. So that's where I kept them as two separate bullet points, right? So first thing is we may have to look at that first, as in just doing a protobuf change first and then see the performance hit and then do the other changes. So according to some people in projects like I think Nutanix or something, so it is considerable just moving from XDR to protobuf itself.
Okay, thanks.
The other part is also that in client layer, we actually maintain a list of outbound requests, and the lookup frame actually goes through a list, which is pretty basic. We may also have to see whether that is also contributing to latency, because if it is a list of like, let's say, like 100 requests or something like that, it will start adding to latency.
True. Yeah, I mean, surely there are a lot of minor changes and also big changes which are possible. I think it is also about number of people who is looking into the code and started contributing into it. So.
Okay, I am stopping the recording.